Okay, so when we have a function, every input can only give one output. One of the ways we can describe that situation is by saying that the function's input determines its output. And so because the function's input determines its output, we have a notation that means the output that corresponds to a given input. We write f parentheses x, and we'll read this as f of x to mean the output of the function when the input is x. So notice that f of x is different from f times x. You have to know from context whether writing these in parentheses next to each other means multiplication or if it means function notation. There's nothing magic about the letter F. Right? We can use other names than F. We can say y of x, so the input is x, and the output is y. We can say a of r, so the input is r, and the output is a, and so on. We can say v of t, whatever variable names we want to use for our input and our output. When we're working with real-life quantities, when our variables x and y mean something in the real world, we will often use function notation rather than writing an equation in two variables. So instead of writing y equals 2x plus 5, for example, we'll write y of x equals 2x plus 5. And what this does is to give us a convenient way of saying what input we want. So here we have y of x equals 2 plus 5x. That means y of 2. That means replace every x you see with a 2. So 2 plus 5x. And the input is a 2, so we'll replace the x by a 2. That'll be 2 plus 5 times 2 is 10, or 12. So with this function, y of 2 equals 12. That means that when the input is 2, the output is 12. Let's see some examples of working with function notation. In business, it's common to use something called straight line depreciation to describe the way that the value of a piece of equipment decreases over time. Right? So you're a business and you buy a truck for $30,000 or something. And then your business has this $30,000 asset. And sometime in the future, the truck is going to stop working and you'll have to throw it in the garbage, and then your business won't have a truck anymore. Instead of saying that the values of your business just decreases by $30,000 when the truck stops working, businesses will use depreciation to have the truck lose value gradually over time so that they're not, on paper, suddenly out $30,000 when a truck they've been using for a really long time suddenly stops working. So in this example, we have a function v of t, which it says equals 2000 minus 100t. And we say this describes a relationship between t, the number of years since a tool was bought, and v, its value. So notice the way we're describing these variables. We give the symbol for the variable and then the real world quantity that the variable represents. So t represents the number of years since the tool was bought. V represents the tool's value. So v of 0, right, that means in the equation for the function, our input is t. V of 0 means everywhere you see a T, replace it with a 0. So 2,000 minus 100 times 0. 100 times 0 is just 0. So this is 2,000. V of 0 is 2,000. We can interpret this as, so T is the number of years since the tool was bought. So 0 years after the tool was bought, its value is $2,000. Or there's another way we could phrase this, right? 0 years after it's bought, that means it's new. We could phrase this as, the tool was worth $2,000 when it was new. Which way should you phrase it? Whichever one you like better. I think that this one is more informative because 0 is a special number in this case. Okay, V of 10. Right, that's 2,000 minus 100 times 10. 100 times 10 is 1,000. So this is 2,000 minus 1,000 is 1,000. V of 10 is 1,000. How do we interpret that in context? Well, this is telling us the value when T equals 10. So T equals 10 means 10 years after the tool was bought. What was its value? V was 1,000. Its value was $1,000. 10 years after it was bought, its value was $1,000. So notice, function notation is telling us what input to plug in. And then what the symbols in the equation mean is telling us what those numbers mean. Let's see an example where instead of having an equation, we're given our function as a table. So this table shows us the input is the number of items we buy, and the output is the total cost C. So we're buying some item in volume. We're buying 1, 2, 3, 4, or 5 of some particular item. And we can see in the table that this is a function because the inputs are all different. If we want to find C of 2, that means we're trying to find the output associated with the input 2. Right. So what's in parentheses will always be the input. And then the result is always the output. To do this in a table, well, we find the 2 among the inputs, and then we see what output that's associated with, which in this case is 15. C of 2 equals 15, and the way I'm going to give this interpretation is kind of making the 2 the subject, right? So when we buy 2 items, we'll say the cost, right? C represents the cost. The cost is $15. So when we buy 2 items, the cost is $15. That's our interpretation of C of 2 equals 15. In this next part, notice we have a blank for the input. And we're told the output is 25. We need to find the input associated with the output value 25. And in the paper, there's a typo. We're looking to find the input associated with the output 25. So we find 25 in the output column. And then we look back and see what input is associated with that. The input 4 is associated with the output 25. When I write this interpretation, I'm going to write it to kind of make the 25 the subject. So the cost is $25. So when the cost is $25, for a cost of $25, what happened? We bought 4 items. We could also phrase that the same way that we phrased the previous. We could also say, when we buy 4 items, the cost is $25. But since the question we were asked was a question about 25, it makes sense to make that the subject of the sentence.